Pain moves faster than you think. You touch a hot stove, and before you even realize what's happening, your hand jerks away. The pain feels immediate, almost explosive, as if the heat itself raced straight into your mind. But here's the strange part. Pain doesn't actually exist in your skin. It doesn't live in your finger. So how does that sharp, burning sensation travel from your hand to your brain in what feels like an instant? What path does it take? And why does emotional pain sometimes feel just as real as physical injury? Because pain isn't just a feeling, it's a message. And today, we're tracing its journey. Welcome back to Simple Things Why and How, where we uncover the hidden processes behind the sensations you experience every day. Pain is something we all understand, not academically, but personally. It can be sharp, dull, throbbing, sudden, lingering. It can protect you, warn you, or overwhelm you. But beneath that experience lies an intricate communication system designed to keep you alive. To understand how pain travels, we need to start at the moment of impact. Scattered throughout your skin, muscles, and organs are specialized nerve endings called nociceptors. Think of them as tiny guardians constantly scanning for danger. They respond to extreme heat, intense pressure, chemical irritation, anything that signals potential damage. When you touch something dangerously hot, those nociceptors don't feel pain the way you do. Instead, they detect a threat and convert it into an electrical signal. That signal begins its journey along nerve fibers, long, thin pathways that stretch from your fingertips all the way to your spinal cord. And here's where it gets fascinating. Not all pain travels at the same speed. There are two primary types of nerve fibers involved in pain transmission. The first are fast fibers, often called A-delta fibers. These carry sharp, immediate pain, the kind that makes you yank your hand away before you consciously process what happened. They are insulated, allowing signals to move rapidly. Then, there are slower fibers, known as C fibers. These carry the dull, aching sensation that lingers after the initial shock. That's why when you burn your finger, you feel two waves. First the sharp sting, then the deeper, throbbing discomfort. Pain arrives in layers. Once those electrical signals reach your spinal cord, something remarkable happens. Before the message even reaches your brain, your spinal cord can trigger a reflex. It sends a motor command back to your muscles, causing your hand to pull away instantly. You move before you think. This reflex arc is your body's emergency response system, bypassing conscious thought to protect you from further harm. But the message doesn't stop there. From the spinal cord, the signal travels upward to the brain. And this is where pain truly becomes pain. Here's the surprising truth. Pain does not exist until your brain interprets the signal. When the electrical message arrives, multiple regions of your brain activate. One area processes location, where is the injury? Another evaluates intensity. How serious is it? Others link emotion. Is this frightening, alarming, distressing? Your brain assembles all of this into a single experience. That burning sensation, that ache, that sharp sting. Pain is not simply detected, it is constructed. Which explains something profound. Have you ever been so focused on something, a game, an intense conversation, an emergency, that you didn't notice an injury until later? That's because your brain can amplify or dampen pain depending on context. In moments of danger, adrenaline and other chemicals can temporarily suppress pain signals, allowing you to act. On the other hand, anxiety and fear can intensify pain, making it feel stronger than the physical injury alone would suggest. Your brain is constantly interpreting whether pain should be prioritized. Pain is not just about damage, it's about meaning. Interestingly, emotional pain, heartbreak, rejection, grief, activate some of the same brain regions as physical pain. The brain doesn't entirely distinguish between social injury and physical injury. Both are threats to well-being, which is why a broken heart can feel physically heavy. Pain, in all its forms, is the brain's way of demanding attention. So how does pain travel through the body? It begins as a detection of danger. It moves as electrical impulses along nerve highways. It triggers reflexes for survival. And finally, it is interpreted, shaped into experience by the brain. Pain is not your enemy. It is your alarm system. Without it, you would not pull your hand from the stove. You would not rest a broken bone. You would not protect a wound from infection. Pain keeps you alive, but it also reminds you of something deeper. You are not just flesh and bone. You are a network of signals constantly communicating, constantly protecting itself. Every ache, every sting, every throb is evidence of a system working tirelessly on your behalf. The next time you feel pain, whether sharp and sudden or quiet and persistent, remember that beneath the discomfort is an extraordinary chain of communication designed to protect you. If this helped you understand your body a little more deeply, give this video a like so more curious minds can discover it. Share it with someone who loves learning how the human body works. And subscribe to Simple Things Why and How, because the most ordinary sensations often hide the most remarkable stories. Until next time, stay curious and take care of the body that's always looking out for you.